Thank you, sir. Good evening, team. I have posted a poll. Please just post your views. Actually, I asked you in which year of your study you are all there. So that will give an idea. So, like, what kind of an audience and at what level we can take this session. So accordingly, I'll calibrate. So here is the poll. So you can enter so you can enter your response there. Okay, you can quickly enter which year you are actually, which year. Yeah, Ajnesh, you have a question? Okay, so I'm going to the session now. So we will. Jebin, you have a question? Okay, so we'll start the session. So you can continue posting your this thing in the poll. This thing. So we have this challenge, electric four-wheeler design challenge. So this is a kind of a 1 year event actually. And what exactly we will do in this awareness session? If you look at the agenda, so we have roughly about 5-6 slides, and so the first item is what is the purpose of this event actually, electric four-wheeler design challenge. What is the purpose? And what is the cost and the benefit of participating in this event actually? So that is the second agenda item. The third item is how this event will be run, like a kind of event flow, like how we will start and what are all the various stages of this event, and then how this will conclude as final event actually. So that we will discuss. Then who are all the organizing committee members of this event actually, and what kind of background they bring to this event. And the last last item on the agenda is question and answers. Okay, so I'm now going to the first item, purpose of electric four-wheeler design challenge, or why a student should participate in this event. So the challenge we have today is All India Council for Technical Education has set some requirements for awarding the BE or BTech degree. So the requirement is something like this. You need to get about 160 credits over 4 years. So this 160 credit, okay, it could be a theory paper, or it could be a lab, practical, or it could be a project actually. So all combination, this thing. And so what really happens here is, so the entire 4 year, we get exposed to the theoretical aspects of, let's say, mechanical engineering, or if you're from electrical engineering, mostly the theoretical aspects actually. But if you go to industry, the first challenge is first of all, you need to understand what industry is doing, right? Industry different industries do different things. Some industries are in the manufacturing, some industries are in the business of designing and manufacturing and things like that. So it is a very, what do you call, kind of a wide spectrum. Okay, so now if you look at a company, typical company, okay, they work using many what do you call engineering documents. Okay, so like you have a design specification, it's an engineering document. So you have this CAD models and drawings actually. So this is again an engineering document. Okay, so then you have bill of material. Then you have like what do you call a prototype testing documentation, prototype building documentation. Then you have like quality control procedures. Then you have like production documentation. Then you have what do you call kind of service manuals. So it goes on actually. Now, if you take just only CAD modeling and drawing, there are about 6 or 7 deliverables actually. Like you have a 3D part model, a 3D assembly model, 2D part drawing, 2D assembly drawing. Then you have an exploded view. Then you have this mass property calculations. There are about 80 mass property calculations which we can do with a CAD model. Now, these are all the expectations from the industry. Now, if you look at a typical lab, like a CAD lab in our curriculum, we do a few exercises, right? And these exercises mostly are connected, or some of them are not connected at all. Like, you will do one part or you will do one assembly like that. But that doesn't, give the complete picture of what is happening in an industry. So there was the challenge is to bridge the academia and the industry. So that is where this challenge is coming. These challenges are useful for the students. The reason is, as I told you, you need 160 credits, and this 160 credits mostly is around the basically courses, theory courses, lab practicals, and project work. But industry, as I told you, is working completely different. Okay, so they expect engineers to start the work from day one. So therefore, we want to share our experience, actually, what's happening in the industry to the engineering student, actually. We call it a student engineer. The whole idea is to expose what industry is doing so that they get prepared during their college days itself. How does this help actually? They get that hands-on experience. This hands-on experience, basically that experience is very useful actually, because like many students graduate every year from engineering colleges, and it is very difficult to compare people from one college or institute to another college or institute, because if you take your grade point average, like if two students score 9 CGPA, that really gives a very tough kind of a problem for the industry people to assess who knows what and to what extent we can give that kind of a work to that engineer. So therefore, this first, this electric four-wheeler design challenge is a bridge kind of. This gives an experience for student engineers. So that's the whole idea. So that way you are prepared for industry. So you become industry ready, right? So let us go into the purpose. So the purpose is basically this challenge takes students beyond textbook theory. So that is the first and the most important. Basically, what it means is, okay, there is a theory part of it and there is a skill part of it. So this focuses both theory as well as the skill part of it. Now, if you look at the second item in the what you call the purpose, okay, so students get hands-on experience in designing, building, and testing an electric four-wheeler. Okay. Now, a typical event actually, we generally call this as collegiate design challenges. So in this actually, okay, the idea is to bridge the gap between academia and industry. So what are all the things you are expected to do? Okay, so you solve real world engineering problems. So what do you mean by real world engineering problems? Like, like let's say a design can happen at a three level. It can happen in your mind. Basically, it's an idea or a thought. Then this idea or thought can be put in a sheet of paper so that I understand what's in your mind. If because design is a team activity, it is not done by one person. It's done by team. And if you take a passenger car, roughly about 400 people from, let's say, Renault will work from Renault side, and another 400 people, basically engineers, will work from supplier side. So therefore, about 800 people will work in a typical program. Basically, if you take one particular model being launched actually, so that means about 800 people work. So therefore, this is a team activity. Now, if you take a team of 800 people, this is done over 4-year period, roughly. Okay, because testing itself in industry takes about one summer and one winter, and then we will get where or which parts or which systems or assemblies failed. Then we will do some improvements. Subsequently, again, that product has to be tested for one summer and one winter. So that means we test 2 years actually. A vehicle is built, it has to be tested for 2 years. First, one iteration, and then it comes with some improvements. So now if you look at actually, if a particular component, if it is a mechanical component, if it is going to fail, that failure can happen at a part level, or it can happen at assembly or system or at product level. If it happens at part level, so that is called failure mechanism. So typically for mechanical engineering, we have like plastic, elastic or plastic deformation, fracture
Sir,
or
sorry
rupture.
to disturb you. Sir, I can able to see your first slide only. Are you moving the slides?
Sir, 1 minute. Okay, 1 minute, sir. Actually, I'm in slide number. Okay. Okay, sir. Can you see it now? Purpose of
Yes, sir.
electric.
Yes, sir. Yes, sir. Yes, yes.
The purpose of
Yes, sir.
electric four-wheeler design challenge. Okay. So we are discussing about solving real-world engineering problems. So now this is like if a part is going to fail, it can fail in any one of the 6 ways. Basically, we call it as component level or part level. We call it as a failure mechanism. The failure mechanism could be elastic or plastic deformation, fracture or rupture, fatigue, creep, wear, and corrosion. Now, so if a part is going to fail because of any one of these reasons, actually, there is a theory behind these failure mechanisms. We all studied this theory in our classes, but unfortunately, that is not connected with the real world. So that is where the gap is. That gap is what we are trying to do in this design challenge for electric four-wheeler design challenge. So that's the solving real world engineering problem. That's a component level. You have at the assembly level, like or at a system level or at product level, you can have failure modes like no function or partial function due to usage or time. The third one is intermittent function, and the fourth one is unintended function. So it could be any one of these reasons. So basically, our systems, basically this electric four-wheeler is a multidisciplinary design challenge. It is mechanical engineering, electrical engineering, electronics engineering, and control engineering, and some amount of programming is required. So therefore, no, it is multidisciplinary. It doesn't belong to only one what you call discipline. So like I said, for mechanical engineering, we have failure mechanism for electrical engineering also, right? Like that for electronics, like that for control. Like that for software. That means we have a bucket of problems actually to be solved when we design, build, and test a vehicle, especially an electric four-wheeler. So this is solving real-world engineering problems. So to solve a problem, first you need to know, okay, the problem. Okay, what do you mean by knowing the problem? Okay, you build a vehicle, okay, and then you start the vehicle and the vehicle is not moving, then you know there is a problem. It could be at a component level, or it could be at assembly or system level. So obviously, we should develop a process by which we are able to first identify the problem, then look for options to solve this problem, then identify the best option, because it has to be, when we say best option, we call it as optimal solution, right? Then implement the solution. When I say implement the solution, so let's say if two wires are not connected, then connect the wire, then see what happens. If the vehicle is moving, fine. If the vehicle is not moving, obviously some other problem is there. So therefore, we do a kind of a layer by layer. Okay, it is not no, we know the problem and we can solve the problem, not like that. Okay, because we are all only student engineers, so we need to solve this problem. To solve this problem, right, we have to go by a layer by layer way. Like we have to look at first, know whether the wheels are turning. If the wheels are not turning, then go to the what you call kind of a propulsion system, basically the motor. If the motor is okay, then go to the energy storage, basically the battery. Okay, so if all these things are fine, then look at the cables, okay, and the switching circuits. Okay, so this goes by a process. So that's what I want to impress you upon now. Then if you take budgeting, okay, the budget for building this vehicle, actually I'll be sharing more data in the subsequent slides. For the time being, okay, we need to know what are all things involved. Okay, how much you have to spend for registration, how much you have to spend for building the vehicle, how much you have to spend for travel, and how much you have to spend for food or accommodation, right? And maybe any incidental expenses. So this will give you a kind of a budget for the entire event. You should not consider only registration fee, or you should not consider only the what you call vehicle building, because there are other expenses involved, and we need to very carefully plan so that we can what you call control the cost actually. So whatever cost I'm sharing here is basically on the upper side. Upper side means this is the maximum you will be spending. But if there is one student engineer working on the budget, definitely we can control or save the amount spent on this event as a team or as an individual level. Then comes the project management. Whenever we talk about project management, we talk about three things. So what are all the scope? What are all the deliverables? At what level of quality I will get the deliverable? What kind of timeline? And what about the cost? Basically, the budget. Right? So this is project management. And then comes collaboration. Now I told you 800 engineers work in a passenger car, in an automotive OEM side as well as supplier sides. But in this particular event, we will have 25 student engineers working on this particular vehicle. Now, first you need to understand what are all the activities involved. Then you need to split the work. When you split the work, you need to assign that work to one of the student engineers. Now, let's say that particular work is creating a CAD model. So one student engineer will be working on that. Now, another student engineer will be preparing a mesh for finite element analysis. And another engineer will run the, the analysis, okay, so using solver. Then comes the post-processing. Then comes, kind of, the this analysis has answered a question, because all analysis taught is there for a reason. Basically, it is trying to answer a question. So the question could be a pass or a fail. Okay, so this component can withstand the load, or this component will fail. So this is the only question we have in our mind, and for that question only this analysis should answer. So now if you look at these 3 or 4 activities: CAD model, meshing, solver, basically boundary condition, free body diagram, etc. And then lastly, post-processing, and then coming to an inference. Actually, when we make an analysis, we need to make an inference. Now, unless you plan the work, if you don't plan the work properly, that means no, these people will work independently, resulting in delay and budget overrun, and we may not be able to meet the deadlines. So this is precisely what we want to teach you, because this is not taught in the classroom. They don't, in the colleges and universities, we don't teach how you can work as a team, how to get the best output at the most, what you call, lowest cost, actually, because that is frugal engineering. Country like India cannot spend a lot of money in building a vehicle like electric four-wheeler. So therefore, we have to apply frugal engineering. So that means the roles and responsibilities of all the team members must be identified. The same way, the entire work, we call it as WBS, work breakdown structure. So what exactly the entire work is involved, okay, and that needs to be identified. Then people need to be, what you call, assigned to the work. Actually, that's collaboration. Now, collaboration happens only when there is effective communication. In this effective communication, maybe you prepare a presentation, or you present, okay, you present a slide deck, or you present a finite element analysis report, or you present a layout, right? So when you do all these things, actually, okay, so we have identified scores, because if you take the project, entire competition or challenge, okay, we have 3 design reviews: DR1, DR2, and DR3. DR3 is the final event. So at each stage of the event, let's say DR1, the requirement is a master layout. So what are all required from the master layout? Basically, this needs to be prepared by the students. So what we expect from the master layout, and so this is actually the starting point. This is when every one of you start thinking individually as well as collectively, and come with your layout, one layout which you can present to the industry volunteers, who will evaluate your DR1, basically design report for the stage 1 or milestone 1. And that is possible because of effective communication. Now, when we say effective communication, many of you have challenge in, what do you call, writing reports, especially technical report, because this we don't do inside our classroom. Maybe if you are in your final semester, as a part of your project or thesis work, you may do or prepare a report. But please understand, that's at the fag end of your course, not at this stage of the course, actually. So therefore, if you get, let's say you are in the second year or third year, okay, you get an opportunity to write a report or prepare a report and present a report, that means it means a lot to you, right? Then you'll also get connected with the industry. Basically, when you interact with the industry people, okay, you get an idea for planning your career path, okay, whether I should be a designer or an analyst. Actually, if I'm going to be a designer, then what kind of CAD packages and other calculation tools and things, okay, deliverables I need to master, so that is, you can interact with industry volunteers and get to know what kind of opportunities exist in the industry, and also you can get or plan your career path. And in this process, like when you solve real world engineering problems, when you plan and prepare budgets, when you do project management, when you collaborate and work as a team, and the communication is seamless and effective, right? Then you are ready for industry. Now, when we do all these things, we expect you to work in a safe environment. Please understand, this is not a Baha event. In Baha, it's a race. Our intention is different, because we don't want to put student engineers in a kind of a unsafe environment. Okay, because please understand, okay, your what do you call education, everything is supported by your parents. Obviously your parents are very much interested in you preparing and completing your course in a nice fashion. They are not interested in you getting into some kind of situation where this is likely to affect your life or your career, which we are not interested in getting into that. So therefore, if you look at the purpose of this, okay, design, build, and test electric four-wheeler. So this is the whole purpose. Now you can ask, sir, why I should do this? Because do understand this is not in your curriculum. Maybe many of the elements we will be doing in this is there in the curriculum, but you need to appreciate the difference actually. The difference is there is an academic level and there is an industry level. If the academic level is, say, let us say on a score of 0 to 100, academic level is at 35 or 40, the industry level will be at 80 or at 85. So this is the gap. This gap needs to be reduced. If we are able to reduce the gap, okay, using this what you call challenge as a kind of a what you call a vehicle, right? So that means no, our chances of getting what you call recruited by industry is high. This is not a promise by any chance actually of you getting placed actually. This event is very clear. This will build competency so that you are industry ready. Okay. Participating in the industry doesn't mean you will get a job, because everybody can register for this event, right? So obviously the people in the final year, okay, they will move, basically they can go for an interview because they will finish the course in June July 2024. So obviously, so they will graduate. So first requirement is first you have to graduate. If you are in the second year or third year, your chances of getting a job, because you are not finished your course. That's first challenge. Second challenge is, you please understand, there are many people who pay the fees and they don't take it very seriously. That seriousness can be, I can put or can give some kind of a scale from 0 to 100. Some students just register for the heck of it because they want, they are rather they expect only fun. Please understand, this is not a cultural event. This is an engineering event. So obviously there must be some incentive for you to participate. That incentive is to prepare you for the industry. What kind of competencies are in demand in industry? We understand it. You can see the article who are all part of this organizing committee, and you'll know. So our background can help us to identify what kind of competences are of interest to the industry. So this event is designed based on that, meeting that requirement. So therefore, you can be assured, okay, you take this seriously. Even if you take this seriously by say 50%, there is a very high probability. How much I can give? Say 75%. 75% of the probability you have of getting a job. Okay, even if you only put 50% effort. Okay, if you put more effort, your probability will improve. Many a time people don't put effort, necessary effort. People think by registering for this even they will get a job. Okay, and that is not correct actually. You have to register, you have to attend all the workshops and training sessions we organize, and you have to give all the deliverables on time, and you need to get evaluated by the industry people. They will share the feedback to you. I will share the feedback for the last event for 1 or 2 teams, depending on whether the time permits. Okay, so therefore the whole idea is, okay, give the students a chance. Okay, then what do you mean by give the student a chance? Actually, this curriculum is not there in your syllabus, obviously, right? So therefore, if the curriculum can prepare you for industry, fine. we are all will be really happy. Okay, but if the curriculum, okay, there are some gaps, like it deals with the theory, it deals with the practicals, it deals with the project, but the industry expects more. The expectation is more. Therefore, it is very, very important that we prepare ourselves for the industry. So if we prepare ourselves for the industry, then there is an opportunity, then we can make use of that opportunity because we are already prepared. There is an opportunity, but if we are not prepared, then we don't get a job. Right? The same way, you are prepared, but there is no opportunity, it is a wasted preparation. So please understand. You need preparation, you need opportunity. Opportunity, you can see the market is coming with more and more electric vehicle. That means industry is interested in more and people, more engineers, basically skilled or trained in electric vehicles. So therefore, the market opportunity is there. Even the government of India is telling by 2030, all vehicles sold in Indian roads will be electric. But I'm very, very doubtful whether that target can be met, because today industry is selling, as per SIAM report, around 40 lakh vehicles in Indian roads, four-wheelers basically, as their cost. That means you cannot, within next 6 years, you cannot, you can make all these vehicles electric, because basically even industry is not ready. Okay, like there are challenges in battery, there are challenges in the motor. Okay, there are other challenges there, lightweighting. So we can go on. So all these problems needs to be solved. Solved by whom? Solved by the graduates who are likely to graduate in the coming days. Okay, so therefore there is an opportunity, but unless you are prepared, you cannot make use of this opportunity. So if you are in the second year, that means you got a long runway. What do you mean by runway? You got second year, third year, and final year. That means that's a long runway. Suppose you are in the final year, your runway is very short, because your runway will be over by June 2024. So please mind it. If you are in the final year, your runway is till June, July 2024. If you are in the third year, June, July 25. If you are in the second year, your runway will be till June, July 2026. That means those people in the second year and third year, their probability of getting or acquiring these skills, and the market is ready for engaging them or employing them, right? So they will be prepared and they must be ready, right? So I'm going to the next slide. So let us look at the cost benefit of participating in this electric four-wheeler design challenge. Now, first let us look at the cost actually. Now, actually, they already shared the brochure in our WhatsApp group. Maybe once the session is over, again I'll ask them to post that, what do you call that, flyer. Okay, as per the flyer, actually, the team registration fee is rupees 59,000. That includes GST also, and that's the registration fee. That's fixed. But if you look at the vehicle building, okay, the vehicle is expected about 200 kg. Okay, so our intention is the cost should not exceed 2 lakh. Okay, because per kg we have put about 100 rupees. So that means you got 200 kg vehicle, and average cost, okay, for per kg is about 100 rupees. Okay, so therefore you are roughly about 2 lakhs actually. Okay, sorry, 200 kg, and the what do you call the cost per kg is 1000 rupees. I'm sorry. So 200 multiplied by 1000, that's approximately 2 lakh. But if you are very smart, you can definitely reduce the cost. The vehicle building cost is not fixed. This is the upper limit I'm giving. Right? How much you can reduce? Okay, please understand. There is a requirement. Your vehicle has to meet certain endurance limit. If you can pass the endurance limit, that means no, that's just enough. But that is part of the what do you call it, competition rule book actually. Okay, how much endurance your vehicle is to cover. But we have built to prove, okay, we can build a vehicle under 2 lakhs. Okay, we have a vehicle during the workshop. Basically, we conduct many workshops as a part of this program. Okay, during the workshop, we will demonstrate, okay, with the actual vehicle and with the bill of material. We will also dismantle the entire vehicle so that there is no hidden cost or anything like that. And you can see how simply you can take photos or whatever you want to do. Fine, right? So our expectation is if you're spending more than 2 lakhs, I think that is means bad engineering. You are not doing engineering. Okay, so that is vehicle building. Now you look at travel for attending workshop and for final event, approximately for 25 people, I put something like what do you call 75,000 rupees, and for accommodation another 75,000 rupees per person. I'm putting about 3,000. Okay, but how many people will attend at all? I really don't know. I put it for maximum. And any incidental expenses like you may incur something like what do you call, you may need some local travel to buy some components or items or something like that. Okay, something which you cannot budget, that's incidental. That's about 41,000. So cost per team is likely to be around 5 lakhs. This is the highest you will be spending. But we will teach you, right, how to do the entire thing at the most what do you call frugal way. Okay, my suggestion is between 30 to 40% of the cost. That means 30 to 40% means roughly you can do the entire thing in 3 or 3.5 lakhs. That's the kind of thing we expect. But this is on the higher side because I want to give you some numbers. So therefore, I've given the worst case figures. Now look at cost per person. Okay, so the cost per person. Okay, so cost per team is 5 lakhs. So that number is has to be corrected. Okay, so that's 5 lakhs divided by 25 people. That's roughly 20,000 per person. Okay, so this is the what do you call per person what do you call investment. All right. So now let us look at what are the benefits. Now, if you look at the benefits, actually, right, the training for students actually, there are workshops. That workshop is part of the what do you call this program. Apart from that, because we need to build the competency so that the student engineers can be industry ready. There are about 11 modules, and if each student is going to be trained, so this 11 modules for 25 students at the rate of rupees 650 is roughly about 1,75,000 rupees. So that is the value of the training. Okay, so how many people will attend, how many modules they will attend, really I don't know. Okay, so this is the maximum benefit I'm sharing. And if you look at the electric 4-wheel prototype, the vehicle itself, okay, I said the building cost is 2,50,000 rupees. So that's a prototype. Okay, now we have designed this competition with the certain things in mind actually. For the first year, you'll be spending about 3.5 lakhs for building the vehicle. But subsequent year, you will be spending less. Why? Because there are many reusable components like your motor, your battery, your tires, your steering system, your braking system. We call it as carryover parts. We expect every student team to carry over the parts. That means the team which is working this year, and there is another team from the same college working next year, okay, they can take about 70% of the part to the next year. That means that much cost will be saved actually. At least our expectation is, because once the competition is over, we are not going to do anything with the vehicle. Okay, and the structural part of it, we expect you to not reuse actually. Your motors, your batteries, your steering, your brake, your tire, this you can use. But other things we don't expect you to use. That is likely to be 30% of the cost. That means first year, let's say you are spending 100 rupees, okay, for your team. The second year, you will spend only 30 rupees because other parts and all you have already available with you. So that's the prototype. Okay, that's about 2 lakh. And if you look at opportunity to learn, connect, and share with the industry volunteers, okay, roughly I'm putting, okay, we will be arranging some industry lectures. Okay, we are expecting around 10 industry lectures in the final event or during the event. Okay, so each one, let's say, worth about 100 rupees per lecture. Okay, so this is roughly equal to per team. This is about 25,000 rupees. And there is a prize money. This is only applicable for winners, not for everybody. So that means the total prize money will be around 2 lakhs. Now look at the hands-on experience, which is in demand, what do you call, in the industry. Okay, so we put some number. Okay, you may like that number, you may not like that number. Based on my experience, I am putting a number. Okay, how I arrived at that number I'll explain a little later. Okay, now I am putting for that a value of about 4 lakhs. Now assume, okay, you have topped the, what do you call, overall team rank. That means your team is the best team among all the teams. Assuming that, okay, there are 25 students and each one is getting a placement. Okay, and if they are getting about 5 lakh per annum salary, okay, that will translate into roughly about 1.25 crore. Okay, so if you look at the total benefit, that's roughly about 1 crore 35 lakhs. Now, what you are getting by way of training or the electric four-wheeler prototype, just ignore everything. Still, you will get 1.25 crore if every student is going to get placed. So therefore, my this thing to you, challenge to you is one. First, you get 25 team members join. Bring 25 team members, form a team, and register. Then work really hard because this electric four-wheeler event will help you to get a job with an average salary about 5 lakhs. Somebody is really smart, maybe you will get more salary also. But I put some average numbers. All right. Now that is the big thing. So the benefits for the team 1.35 crore. Now let us look at the individual level. Okay. So that will be about forget about that 40,000 this thing. So let's say only your 5 lakh salary. Right. So what is the investment per person? Investment per person is 20,000. Now what is the benefit? You get a job. Okay. So, sir, is there any guarantee? That's what I'm telling. I cannot give you a guarantee, but I can expect one thing from you. If you work hard, you strictly go by the deliverables and quality of the deliverables, you just follow the instructions. This probability will move from 0 to 90 or 92. That means probability of you getting a job with a salary of 5 lakhs per annum. But if you do a shooty job, okay, your probability will be low, less than 10%. So therefore, it depends on what you do. You do really good, okay, we are there. Okay, we'll see that you get placed. We will arrange some placement interview during the event. Actually, we tried to do last year, and a couple of boys got job offer from Ola Electric because one of our management committee member happened to work as a senior manager in Ola Electric design studio, so he could get some offers. But please understand, these are all really very rigorous, and only not everybody will get a job. That be clear. Okay, so this is the benefit. Now, what is the investment and what is the return we can expect? Like 1:25. You invest 1 rupee, you are likely to get 25 rupees worth of value. But please understand, this value you will get only if you invest in time and regress. What do you call it? Follow the instructions rigorously. So this is the cost benefit analysis of this event. Now, how does this event flow? Okay, first is the team registration. Second is we'll be conducting many workshops related to the rule book, related to how do you prepare the master layout, the various deliverables. Then you will do the design. Okay, so the design review 1 is the master layout. Actually, design review 2, there are deliverables like CAD models and drawings and other electrical circuit diagram. Everything will be there in design review. Then the volunteers, industry volunteers, from SAEISS visit your college to approval to build. That means no, unless we are satisfied with your, what do you call it, the engineering documentation, we are not interested in cutting the metal. Okay, if you cut the metal, that is not a good practice. There will be some penalty points. Then once you get the approval to build, then go and build the vehicle using those engineering documentation. Then the design review 3 is the final event where you will get an opportunity to test the vehicle. Okay, you will not only test your vehicle, you can also see what other teams are doing. So this is the simple event flow. Now, who are all the organizing committee members? Sir, you are able to see organizing committee members slide?
Sir,
Sorry?
no, sir, not
No,
yet.
sir.
How about now?
Cost, sir.
Cost slide only I can see.
No, this, no, sir, 1 minute. 1 minute, I'm sorry. Okay, you could see the event flow slide. Hello?
Yes, sir. Yes, sir. Yes, sir. Now it's visible, sir.
Yeah. So now I'm going to, this is the event flow slide. Then I'm going to the next slide, basically, who are all the organizing committee members. You could see the organizing committee members.
No, sir. It's not yet changed.
Okay.
Now it is okay, sir.
Yes, sir.
Okay, sir. So these are all the organizing committee members. Actually, Dr. Rajendran is the current chairman of SAEISS. And I'm Shanmugam. I'm a former chairman. And Mr. R.A. Armstrong is also a former chairman. And Mr. T. Kasiraja is the treasurer in SAEINDIA. Dr. Starwin is the joint secretary in SAEINDIA Southern Section. Dr. Hariharan is the secretary SAEISS Tanjavur Division. And Mr. S.S. Nallaberamal is MC member in SAEISS. And this is a good balance of both academia and industry. We have Dr. Hariharan, Dr. Starwin, and Dr. Rajendran. They are all from what you call academia, and others are all from industry. Now, we have put together a good team of industry volunteers who will help us for conducting the workshops and the training, various training, because we have about 11 training modules. These training modules will be delivered at a different period in time, both in physical as well as online mode, actually, right? And apart from that, we have judges from industry. Okay, and we also expect more companies participating for recruiting engineers from this event, actually. So this is the organizing committee members, and we have our own roles, actually. Each one of us have different roles. So I am working on the, what you call, placing the best students, actually. So I'm working on a target of about, placing about 20-30 students, right? Because based on our last year feedback from industry as well as from the student participants, we think this is a high priority area where we need to focus, and I will personally attend to that, actually. Okay, so now, okay, I'm sorry, I'm going to the next slide. So now, so are you up to the challenge? This is my question. So if you are up to the challenge, speak to your faculty advisor, form a team, register the team, then attend various workshops and training programs, and design the electric four-wheeler, share your design review 1 deliverables, get feedback from the industry volunteers. Then you have the DR2 deliverables, design review 2 deliverables, get the feedback from industry volunteers, get approval for build, then build the electric four-wheeler, finally attend the final event. So this is the sequence of events. So we planned for this competition. Okay, so now I'm going to the next slide. And next slide is questions. You have any questions? You can ask me now. You please unmute and you can, what do you call, you can ask your question. Dr. Uday Kumar, you have any questions?
No, sir, no. I know.
Okay, Dr. Sarvin,
No, sir.
you have any questions?
No, sir. No, sir.
Okay. I really appreciate that more than about 1 or 2 students have attended this session. But if you don't ask question, maybe you can ask questions in Tamil also. I can answer, not a problem. But please ask questions. I have already shared some videos last year. What do you call, electric four-wheeler design challenge videos in our WhatsApp group. I'll again ask the office staff to share the link. You can go through that videos to get a feel of it, actually, how the event was done last year. Hello, is there any further question?
Sir, there is a question in chat box.
Yeah, please. I'll go through that, sir. Yeah. Ebenezer, actually, can you say, is this workshop only benefit for mechanical and electronics? What is AIDS, sir? Artificial intelligence and data science. Is that correct? Is my understanding correct?
Yes, sir. Yes, sir.
Yes, sir.
Okay, artificial intelligence and data science. Yeah, it is applicable for artificial intelligence and data science also. Actually, students from mechanical, electrical, electronics, control, and basically what you call this computer science branches like computer science or even AIDS can participate in this event, actually, because we can instrument and collect data, actually. So when we instrument and collect the data, that portion is data acquisition. Once we start uploading this data in the internet, then it becomes IoT, right? And these data you can start, analyzing or doing some kind of this thing to improve your performance, actually. Okay, so I have some videos, actually. This is done as a part of this Autodesk Fusion, actually. Autodesk Fusion has designed chassis, vehicle chassis, using artificial intelligence and machine learning. Okay, and so I'll share you the link, Ebenezer. You can Ebenezer Lanata. You please go through that and you will get some idea. Okay, how this is this can be what do you call AIDS can be applied, actually, because there are two things you can do in Autodesk Fusion. One is you can generate basically design alternatives. That is one. Another one is we call it as basically the model in loop, actually. Model in loop is basically you build a prototype, instrument the vehicle, and start pumping the data in the internet, basically to a data warehouse. From that data, you can analyze and start improving the vehicle. Basically, failure mechanisms you can prevent, or you can improve the performance or endurance. So all three are possible. Ebenezer Leneta, have I answered your question? Okay. If there is no more question, then we can conclude the session. Is the workshop okay? What is this? Is this workshop this through online mode? No, there is two parties here. There is workshop, which is related to the event mostly, like, how do you, prepare a master layout? How do you prepare the CAD model? So all these things actually. So in whatever the workshop, this is physical, but there are certain training modules. There are about 11 training modules in different area. This is delivered through online because we want to reduce the cost of this program, because you stay in Chennai, average per person may have to spend about at least 1,000 rupees per day. So that means the more time you stay in Chennai, that means you stay for 10 days, that means you have to spend 10,000 rupees. We wish this event could be done physically because that will be more effective. But unfortunately, we also need to think about the cost actually. Okay, so our plan is a combination of physical as well as online. Basically, it will be hybrid mode, right? So I hope you understand why we have taken such a decision, because the workshop will be physical in class, and all the training modules will be delivered through online, only to manage the cost for the participants, not for us actually. It doesn't really cost whether it's a physical session or an online session for SAE. Okay, it's only for the participants, because we want all the students to be trained in, basically they get exposed to all these training modules as well as the physical workshop. Okay, so this is some kind of a midway. This is not perfect, but this is under the current circumstances, considering the cost, this is option available. Divya, Divya Darshini, did I answer your question? Okay, sir. Uday Kumar.
Yes, sir. Yes, sir. Yeah. Thank you, sir. Thanks for your valuable input to the students and to give awareness for this challenge. I am very thankful on behalf of SAE Southern Section Tirunelveli Division for your valuable lecture and worthful interaction with the participants. Thanks a lot, sir.
Thank you. Thank you.
Thanks, sir. Starvin, sir. Thank you very much.
Thank you, sir. Thank you so much, sir. Thank you.
Yeah. So, participants, thanks to all for your patient attending this seminar. Now you can disconnect. Thanks a lot.